Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Let's do this board next. Ribbon jumper on here. It's got this cable tie slipped around it, which is a little bit interesting, but that's okay, let's slip it out of the way. Obviously someone's done that to try and secure it for some reason, maybe I don't know, it rattles around a little bit or something. It does, maybe it's fell out, I don't know. But okay, let's try and wiggle the thing out. It's being quite stubborn, doesn't want to wiggle out. There we go, starting to get some movement aside. There we go, starting to go. Alright, so look at the back of the board, see what this one looks like. Well, it's looking okay, it's looking old, but you know, it's looking a little bit dull. Otherwise it looks fine. I can't see any obviously bad joints or anything like that. It doesn't like to be reworked or anything like that, so nothing on that one, I think. Alright, so let's get this cap here out and replace that one, which is another 25 volt 1000 UF, same as before. Yeah, seems fine. Not easy. That's easy enough. Clear the holes. Two presents. Here's our. Should give it the same result as the other cap if it's any good. So that's 850. It's a bit lower at 1 kilohertz. What the other one was 950 something, wasn't it? 957 or something. Let's get down 100 hertz. 956.2 ohms. Yeah, it's a little bit lower than the other one. So maybe the other one was on the way out. It's hard to compare. I mean, so 20% tolerance makes it a bit hard to actually judge. These are Sprague caps, so they're decent quality ones. I don't like to use cheap capacitors at all, ever. Unless it's a piece of gear which is not really that important, maybe it's, you know, a consumer device rather than a piece of electronics test gear. Same where it doesn't have a long lifetime anyway, and it's not really worth putting an expensive capacitor in there when a cheap one will suffice, because it will do, you know, adequately for the life of the device anyway. But when it comes to electronic bits of test gear, then I want these to have a long life. I don't mess around with them. I want to be good for a long time. So I don't know, come back and revisit these things in 20 years time, whatever. Rather just do it, or even 10 years time if you use cheap caps. But 10 years for a consumer device is probably absolutely fine. For this, no, I want this to last a long time. Give it clean, and we'll put it back in. So nothing obvious with the cap so far, which in a way is a little bit disappointing because you always want to find something. But at least I know then the caps are okay, they're done. I'll do. Let's put it back in. Now I have taken a power supply card out once already because I was looking at it. So that one should actually come out a little bit easier. If I plug that in next, I'll have to slip that cable tie back around it before that. So there you go, it's coming out much easier. Already pulled that one out once, and it's got these other. It's got slightly less surface area to pull out as well because it's only got those pins. I've just changed how I'm doing this. What I was doing before was using the LCD monitor on the camera, right, which is about that big. So it's a bit hard to see the focusing. You can get an idea, but it's not that easy to see. So what I've actually done now, I've hooked up a HDMI cable to the camera, which is feeding through to a monitor on my desk, which is over there, and now I can see it much bigger, and it gives you a better idea of the focus. I don't know, if I look at it like this, it looks fine, but when I'm looking at the board, it looks like maybe it's off. 235 volt 2200 UFs, 25 volt 100 UF, two of those, 16 volt 15,000 UF, two of them, and a couple of radials. 16 volt 220 UF. So I've got a few caps there. Was it 8? 2, 4, 6, yeah, 8. 8 caps. Oh, another one over here. 9 caps to replace, which is another 16 volt 220 UF. So I've got 3 of those. So I actually quite like the fact they keep the capacitors in the same kind of values where they can. Obviously reduce the BOM costs and stuff like that too. But okay, let's start pulling things out. So I might just do these easy ones first, or the supposedly easy ones. So I want 220 UF, which are over here, and Digicons. That's a 63 volt, and it's almost the same size, only slightly taller. Don't need 63 volt, do I? That's Nichicon 25 volt, which is still an upgrade, and it's smaller. So I think I'll go with those. Let's get these out. At least I've got the positives marked on the back of the board. So at least you've got some kind of reference marking, in case you forget which way around it goes. That happens. Right. Come on, melt. Alright, so one. I'm going to test these as they come out because I want to, again, same reasons, I want to identify if there's any issues. Right. 182, that's quite a way down. It's supposed to be 220, that's more than 20% out. And it's got 0.4 dissipation. What's that in the ESR? ESR 0.36. Yeah, I'll be a little bit suspicious of that actually. It might be okay. I mean, if you compare it to a brand new cap. 0.5, oh maybe it's alright. But the EMAs are down a little bit. Oh, might 1 kHz, let's change the frequency 100 Hz. That might help. So 0.6, 201, alright, that's down a little bit. So yeah, it's a bit high here, it's 0.9 there, almost 1 ohm. But slightly higher value, so yeah, it's probably slightly dry, not too bad. It's not completely gone. I mean, they're not good quality capacitors to start with, so it's not too surprising they look alright. Put that down. This pin spacing is not quite the same, of course. Anyway, it might. Next one. So on these, the square pad is the positive, in case anyone ever gets confused by that. This is one. It's also quite nice having identical caps, because then if you do get one which is whack, you know, way out of whack compared to the rest, you know, hey, that's definitely wrong. So this one's really slightly lower ESR. So yeah, that other one probably was going bad. It's a shame the spacing's not the same. Oh well. Get that one out. Come on, not again. Let's try this one. Bit of toing and froing, but yeah, well, I want to be thorough. You never quite know what you might find. 0.6, 220. This one's a bit lower again. So yeah. So the very first cap did look like it's probably a little bit dodgy. So that's good. Found something. And that was that one there. These are all 5 volt regulators anyway, so it's on one of the 5 volt supplies. So that may or may not be significant. I'm not adding flux because say this flux, this solder has good flux in it, so I don't usually need to add it unless it's looking particularly bad. If I can see it's bad before I start, then I need to add it. But usually if it's looking okay before, then it's probably going to stay okay. Right, that's those ones. So that's the third of the way there. Alright, next ones. I'll get these two smaller ones out, I think. So that's 25 volt 100. Yeah, 100 microfarad. So 100 microfarad. 25 volt. Two of them. Bit of a size difference. What brand were these ones? I think these are Vichys, weren't they? Yeah, Vichys. So, again, good quality caps. Let's test those ones. Kept in the same location, so one furthest away is that side to make sure I knew which ones was which. Try again. So yeah, 1.9 ohm, 95, and 1.8 ohm, 96-ish. Solder those on. One's going to be dirty. You should always try and put the melted solder directly onto the thing you're trying to solder, not the iron. Otherwise you burn the flux straight off and it's not actually getting to the thing that needs it. You want the flux to be activated right at the point where it needs the flux to work. Just in case you didn't know that. Okay. Double check on right around. Nothing like getting that wrong. Okay, that's good. So the next one I'll do is these two here, the 35 volt 2200 UF. So I've got some here. What ones have I got? Those are 40 volt, so they'd be adequate. Problem with these axial type caps is the storage is not so easy as the radial ones. Right, let's get this out. One. Okay. Let's test these ones. Zero ohms? Really? 2 microfarad? Well, the value's close. 0 ohms though, that's interesting. Same again. These ones might be okay. 0 ohms is a bit disturbing though, you have to wonder about that one. Anyway. Right, where's the markings? I bent in the wrong place, didn't I? Further in than that. So it's been pretty uneventful so far. There's nothing been particularly obvious, you know. These have been looking alright, really, which is a bit disappointing because I like to find things that are wrong, not just replace parts which probably don't really need replacing. And I could just save us time and actually test them before I take them out, but you know, it's old, so I'm in here, I'm doing it, let's just replace the things. Yes, they mostly don't need replacing, there's a couple I've been suspicious about, but they don't really need replacing, obviously, at least. I could be wasting my time a little bit, but they'll need replacing eventually, so you know, it's one of these things. They need doing, they need doing. You notice that when I'm cutting these, I'm tilting the cutter over to make sure it's not trying to dig into the solder or lift it. Gives it a bit of flexibility there, so trying to, if you put it right down and snap, it's going to try and pull, and then it can be problematic. Okay. Next ones. Just double check polarity, make sure I've definitely got that right. Yeah, that's good. Now the big ones, they are 16 volt, 15,000 UF, which I do have some from, because I've already stocked up beforehand, and I have exactly 2, because that's all I needed. I'll probably buy some more now. I've actually used those though. That's my last of those. I haven't got any more. I'm gonna have to buy some more. I like to keep a stock of a few at least, you know, so if I get something comes up I can just do it instead of having to wait for a week or whatever to have parts turn up. I mean, I suppose you could kind of say that I'm blindly replacing parts here with no real reason, and that certainly is true, but these are parts which are due for replacement anyway. You know, they're old parts, and they are parts which will fail at some point in their lives. Let's test these ones. Then that's all the electrolytics done, isn't it? After that, I have to move on to other things. So what's this one doing? 30 microfarad, 0 ohms. So it's out by a couple of microfarad. $40 microfarad, 0 ohms. This one's slightly better. So the other one probably was on the way out. It's a bit too low value. It's borderline. It's right on the bottom end of what's acceptable. You know, so with all my, you know, I suppose it's barely within tolerance, but it's not the best. Look at one of these ones. Hopefully without a tarnishing issue. There you go, 15.7. So, yeah, there's definitely improvement there. Okay, let's shop these things in. Then I'll clean it all up and pronounce that part finished. I need to look at the service manual still for those output transistors on that main high voltage board there, because I'm suspicious those have already been replaced once because of the date codes on them. They seem too new. Doesn't quite seem right. Okay, clean it up. Ah, dear. Well, it's been a long day today. Had a very busy day at work. Looking forward to actually stopping. Okay. Right. Well, that's the electrolytic part done. That should self-align those pins. That could be interesting in itself. Oh I'll stick this back on again. I mean, if someone put this on for a reason, I'm not entirely sure what the reason is, but someone put it on. Try and secure it a little bit more, I don't know. But, so I'll just put it back onto. These are both, these balls actually aren't parallel, they angle out like that. Like, you know, like that sort of shape. So the further down it is, the more it wedges on. But, okay, I'll go back in. Now I want to check these two capacitors here. So here's my meter. Make sure they're discharged because they might not be, being they're so big. No, oh. Nothing on that one. Yeah, both fully drained, that's good. So I can check those. Okay. Series capacitance. ESR. Let's see what I can get now. What's the polarity on these things? I can't actually tell. I'm guessing the black will be negative. Let's go with that, shall we? There's a microfarad. Yeah, that's pretty much perfect. 0.05 ohms, probably fine. Yeah, they look alright. They appear to be, you know, okay anyway, nothing of concern. So I think that's done. At least that part is. I've also done all the caps now, so I thought I'd get the thermal camera out and have a poke around, see if I can see anything obvious going on in here. And there are various hot spots around. There's something just down there which is getting warm. Not too bad, it's only about 40 degrees or so. That doesn't seem too bad. I can't tell exactly what it is, one of the ICs down there. Can't see exactly which one, but it's nothing too obviously warm. It seems alright, really. Also, you got the power supply stuff. The middle one's actually getting hottest. And if I click the button, so that is about 48 degrees, 51 degrees there. Come to this one. These are black, so they should be fine as far as emissivity goes. You know, close enough. That's doing like 60 degrees. It's getting just in. And this one here, nothing. So this one here is running hottest. That's second hottest. So that may be a clue about what's going on. There's also these other little ones underneath, which I haven't checked yet. What are they like? That seems okay. That's warm. That one under there is actually quite hot. What's that saying? About 55 degrees or so. That's saying 58. Yeah, that's not about 60 degrees as well. So yeah, that one there is pretty hot. That's hot. So I'm guessing those are the same line. I should actually look at the diagrams for that. And down here, I can't see what I'm doing because I've got the light reflecting in the bloody thing. There we go. I think we can both see now. Okay. Right. So that one there, it's about 48 degrees, 49, 54. Right, so that resistor's getting pretty hot. One next to it's about 53 as well. And that is, let's get a pointer, some which is non-conductive because it's high voltage. That one there and that one there are getting pretty hot. So that may be a clue. The fuse seems alright, it's not getting hot. But also these other two here. That one there, is it? So that old style, these two old style ones here, they're also getting pretty warm. Can I see what they are? It's about 45, 52 or so, that one. Yeah. So there's some temperatures going on there which are a little bit higher than I'd like. Now we've got this big heatsink here which is also warming up, lighting up like a Christmas tree, as you can see. Some of that is true heat, some of it is just emissivity issues. You can see that if you look on here, you've got black dots. Obviously the alignment's out because of the proximity. Right, but there's black dots there. So those are showing as being cold, but obviously they're not. You know, it's like 35 degrees is what it's showing, but it's not actually that because the reflective. Getting the heatsink there. That's like 50 degrees or so around there. Right, so look, 50 degrees in the heatsink, which is fairly warm. It seems it's not actually doing anything, it's just sitting here really. That's on 120 volt setting, so it's 100 volts output is what it's supposed to be doing. If I go to the 1000 or 1200 volt range, it's dropped into standby already. I can hear it whining, and it hasn't dropped out yet. So that's interesting. Normally it drops out straight away. It did go into standby when I had to enable it again on the front panel there. But yeah, that's interesting. Normally it drops out pretty quickly. Now there's some big transistors here, but there's no appreciable heat there. There's nothing showing up at all really, just nothing. They aren't really featuring at all. So it only really seems to be those resistors there, that heatsink, and the power supply heatsinks, which are things which you'd pretty much expect. Come over here and look at this digital board. There's a few slight warm spots, but that's what you expect. I mean, there is some stuff going on, and there's one hot spot right there, see? I do want to try and trace that. I can feel warmth over here. What is that hot spot? I can feel something warm. Right there somewhere. It's right by that white device. Don't know, there's something around there. There's a tantalum right next to it. Don't think it's that. Nah, somewhere on the board there's a resistor right there. Might be R100. There's a fair bit of warmth in that board just there. So I'm not quite sure exactly where it is. It's a bit hard to trace. I really need a high resolution camera. You know, this is only low resolution. I think it's like 80 by 60 or something. It's just not that great. There's definitely something lighting up over there. I just can't quite see where it is. Resolution just isn't good enough. Kind of feel it, but it's not that hot. I know there's like a warm spot on the board over there. That's about it. Can't isolate exactly where it is. It's right around that white part, so maybe it's normal, I don't know. Well, the voltage hasn't dropped out. That's doing 1000 volts right now. Maybe doing those caps has fixed the problem, I don't know. Section here, still around 50 degrees, hasn't got any worse. This one, 67. Yeah, 67, so it's getting pretty warm there. It's getting pretty toasty. And that one that's behind it, it's about 60. So, yeah. That one there is getting very warm. That's a little bit concerning. Seems to be a bit much. Could be an excessive load on the supply. So I can hear it whining, but it hasn't dropped out. Maybe I should actually test the voltages and see what's going on there. Shut it down again. I always take the batteries out, which is why I've got the cover off, because I believe the battery's going to go flat in a couple of weeks. So I'll take one of the batteries out always, just to keep it going. Otherwise, that way it's always ready to use next time. Let's check the voltages and see what's actually coming out of it. Now, it's supposed to be ACs, but we'll check DC first, just in case there's something weird going on there. There's a slight DC offset there. There are some calibration points for that sort of stuff, so probably just calibration will fix that. So I've got it set at 500 volts, it's doing 500 volts. Okay, maybe that's the frequencies. Well, it's probably what I could hear it, because it's 1 kilohertz. I could hear 1 kilohertz tone. So yeah, it's probably why I could hear it. Right, let's wind it up. Yeah, nearly 1000 volts, 1100. 1200 volts. Hey, it's not dropping out. Just at the hundreds of volt range. Yep, 120. Oh, missed the range. 1.2 volts. Yeah, pretty much. 12 volts. Yeah, pretty much. 0.12 volts. Well, yeah, it's in there. Here we go. Okay, so that's there. Back up again, 1.2. Yep. Back to 12 again. 120 volt. I might try a lower frequency and see if I can get the frequency to make it drop out. 1200 volts again. It goes to standby, we go to high voltage. One of the protection features. Overload, right, okay, let's go down a bit. 1100, yeah, 1000. Yeah, okay, so let's just do 1000 volts and let's change frequencies. Let's do 50 hertz. Still fine. No dropping out. 10 hertz. Low as it goes on that one, I think. Alright, let's go to 1000 hertz. So it's doing 100 there. I can hear it now. Kilohertz tone, I can hear it. Won't do anything any higher frequencies than that, so 1 kilohertz. Yeah, 1 kilohertz is as high as it would do on high voltage. And it's doing 1000 volts. That might actually be fixed then. It's not dropping out anymore. I might just do some checking about these power supplies and try and figure out what they're supplying. It does seem to be there's a bit of load on there. It could be a bit of leakage still. But yeah, it wasn't doing that before. I couldn't get it to work properly before, so although I could get it to generate high voltage for a short period of time, it would drop out again after a couple of minutes, and then it wouldn't be able to go back in. So it's looking quite promising. Yeah, it's cool. Looks good.